Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts. Today let us talk about some concepts pertaining to nuclear physics, especially nuclear instruments. Now, whenever radioactive decay occurs, it is usually accompanied by the emission of particles. It could be charged particles such as alpha particles, beta particles, or it could also be gamma rays, etc. Now, obviously, we can't see these, so we can't detect them directly per se, but they need to be detected by indirect ways. Now, how to go about this indirect methodology? So, for that, we make use of some instruments. GM tube is one such instrument. So, basically, G and M, they come from surnames of two scientists. So, Geiger and Mueller. So, the tube is referred to as GM tube, or the counter which is used for detecting the radiation is called as GM counter. Now, the idea here is alpha particles, beta particles, or even gamma rays, they have the ability to ionize neutral atoms. So, this property is made use of in case of GM tube. So, basically, in this radiation detector, you can say it's a modified cathode ray tube, and there is circuitry which is needed to amplify the current and then detect and so on and so forth. So this GM tube, basically it's a sturdy metal case and that is surrounded by a thin glass tube. Now this hollow metal case, the sturdy metal case that we talked about, it is the cathode. So that metal case constitutes the cathode, and the anode is basically a fine tungsten wire. This wire is fixed at the center of the tube and it is insulated from the metal case, obviously, because the metal case is cathode itself. And this particular glass tube, initially it is evacuated, but after that it is partially filled with a mixture of 90% argon, which is at 10 centimeter pressure, and 10% ethyl alcohol vapor at 1 centimeter pressure. Now at one end of the tube, a thin mica window is there, and it allows or it permits the radiation to the tube, and a DC potential of the order of about 1200 volts is applied between the cathode and the wire. Of course, the voltage is adjusted to be somewhat below the breakdown voltage of the gaseous mixture, and there is a high resistance which is connected in series with the battery. Now, whenever a high energy particle enters through the mica window, it will ionize one or more of the argon atoms which are there inside the tube, and this in turn will lead to further ionization. Consequently, there is a massive electrical discharge that will take place and it will cause a current pulse. So, the current pulse through resistance R will produce a voltage pulse, and the electronic pulse amplifier will accept the small pulse voltage and amplify it. So, the voltage pulse produced initially could be in microvolt, but it is amplified to few volt. And this amplified output is then applied to a counter, and each of the incoming particle is going to produce a pulse. So, from the pulse that is received, the number of incoming particles can be counted indirectly. Now, the number of secondary electrons is independent of the number of primary ions produced by incoming particle. The incoming particle is acting more like a trigger to release an avalanche of secondary electrons, the electrons will reach the anode and cause the ionization current in the circuit. Now the positive ions, the argon ions, of course, are going to move slowly, and they will be accumulated around the anode. So they reduce the potential difference to a value that the current in the circuit is stopped. So this needs to be taken into account. Now initially there is some threshold voltage. So for voltage less than that, there is no discharge and no counts. Now between a range of voltage, now it can vary. Now earlier I had mentioned about 1200 volts. So for some tubes it is 1000 to 1200 volts, but for some it is less, even of the order of say 300 to 600 volts and so on. So the number of pulses will increase with the applied voltage almost linearly. And above the threshold voltage, the number of counts remain constant over a certain region. So in the graph, it will be seen like a flat line. Ideally, it should be parallel to x-axis, but we see that when I say parallel to x-axis, the graph is going to be of counts versus voltage, counts on y-axis and voltage on x-axis. But in reality, we see there is a slight increase. It's not exactly parallel. But since it's a flat region, flat like a plateau, this is called as a plateau region. So in this region, the magnitude of pulses becomes independent of the amount of the ionization. And for the operation of this GM counter, this plateau region or the voltage at the center of this plateau region is identified as the operating voltage for operation of this GM counter. Of course, if you go on increasing the voltage beyond the plateau region, then it's not desirable. So we always have operating voltage by finding out the plateau region of the GM tube. Now there is something called as quenching. So when the positive argon ions, they are reaching the cathode, they will dislodge the secondary electrons from the cathode because these ions have larger energies. So those electrons will move towards anode and produce unwanted avalanche. And then it will be as if there is a continuous avalanche. Then how will the counter distinguish between the real avalanche that is due to the incoming radiation and this kind of an avalanche? So in order to avoid that, or rather I would say in order to distinguish, what happens is there is use of ethyl alcohol as a quencher. Sometimes there is self-quenching as well. So this particular process of preventing the undesirable continuous avalanche is basically quenching. So here you want to eliminate this accumulation of positive ions around the cathode. So this ethyl alcohol vapor that was mentioned earlier, 10% of ethyl alcohol, C2H5OH, is going to prevent this undesirable continuous avalanche by taking care of those secondary electrons. And also here the counter will be able to record only the pulses generated due to incoming radiation. Now of course the counting rate of the counter is basically number of counts or number of particles that are recorded per second. Now here there are different entities that one needs to consider. In the next episode, I will be speaking about these entities such as dead time, recovery time, paralysis time, etc. and also talk about some more aspects. Thank you.